Welcome back to Metric Conversion and Dosages. Today we're going to be talking about conversions and specifically conversions between different systems of measurement. The household system, the metric system, and the apothecary system. These are the three measurement systems most commonly used to prescribe medications. The apothecary system, as its name suggests, used to be the gold standard for communicating dosages, but it has since fallen to the wayside to be replaced mainly by the metric system now, but sometimes we still use the household system, such as telling parents how much medication to give their students, a teaspoon, 2 teaspoons. Although now one would hope that a parent would use a medicine spoon such as this one to measure teaspoons rather than a cooking teaspoon, since the medicine teaspoon is at least a little bit more closely calibrated than a cooking teaspoon. This sheet of notes is meant as a reference for you. You may return to it as you are working through the rest of this course until you have memorized all of the approximate equivalents that I'm checking off on the chart. Memorizing the ones that are unchecked is not required, but it will be beneficial to you if you're able to do that. Let's look at some examples. Here's example 1. A newborn weighs 3,200 grams. Convert this weight to pounds and ounces. That's what we do in this country. We're not comfortable yet with the metric system, and if you want to compare your baby's weight to how much you weighed when you were born, you're going to have to do a conversion. So parents often want the weight of the baby in pounds and ounces. Let's accommodate them. 3,200 grams is the amount we're given, so I'm going to put that over 1. I plan to use dimensional analysis to solve this. I have grams. I need to get to pounds and ounces. So I'm looking back at my chart that I have handy, and you should also. Grams, ounces isn't on the chart. Can you find it? We don't want fluid ounces. We don't want a volume. We want a mass or a weight. Therefore, we will need to do an intermediate step. We're going to have to convert this grams to kilograms because I do have a conversion factor between the metric and English systems of kilograms to pounds. So there are 1,000 grams in a kilogram, because that's what the prefix kilo means. That will allow me to cancel the grams. That's good. And then I'd have kilograms, but I don't want kilograms. I want pounds. So now I need another conversion factor. Now I need to convert kilograms to pounds. So from my chart, I know that 1 kilogram equals 2.2 pounds. That means the kilograms cancel, and I have left only pounds, which is what I want. Okay, so my answer is going to be something pounds. I'm going to still need these ounces, but at least I'm getting closer. There are many different ways to do this problem from this point. I'm going to do some more canceling. 1,000 goes in there 1 time, and 1,000 goes in there 3 times. Actually, 3.2 times 1,000 will give you 3,200. Multiplying straight across, 3.2 or 3 2/10 times 2 2/10 gives me 7.04 or 7 400ths of a pound. But we need pounds and ounces. So now we need to separate this 7 pounds. Oops, can't move that in there yet. And this 400ths of a pound. And these are actually added together. 7 pounds plus 400ths of a pound gives us 7 400ths of a pound. So now we need to do a conversion, converting that 400ths of a pound into ounces. We already know that 1 pound is composed of 16 ounces. So we set up our conversion factor as 16 ounces over 1 pound so that those pound units will cancel. We do the multiplication straight across, and we arrive at the value of 0.64 ounces. Not even an entire ounce, but we were instructed to round to the nearest ounce. So I have to round up. Okay, that will give us 1 ounce. So this newborn weighs, and I have fallen into an old habit that's a bit hard to break. We no longer put decimal points at the end of our abbreviations for the units. Don't ask me how old that habit is, you whippersnapper. To complete example 2, we're going to have to use a conversion factor that is not on any of your charts. It is an integral part of this problem. All right, so how many grams of this drug will the patient take in 3 days? Where are we starting? We are starting with those 3 days. Okay, we'll put that over 1, and we need our first conversion factor. What would that be? Okay, we have taken this 3 days, done that. How many grams of this drug will the patient take in 3 days? We're finished with that sentence, basically. A patient is required to take fexofenadine 6 milligrams by mouth by daily, 2 times a day. So for every day, 1 day, there are 2 doses. Okay, 2 doses. And how much per dose? For 1 dose, or 1 dose will be 60 milligrams. So let's see, days cancel, dose cancels, we have milligrams. We don't want milligrams because we were asked how many grams of this drug will the patient take. So you can either get your answer and move the decimal point, which is a fine thing to do, or you can say there are 1,000 milligrams in 1 gram. That will cancel all of our units. 2 times 3 is 6, and 6 times 6 is 306 grams divided by 1,000. So now I can take that 360. I have a decimal point here, so 1, 2, 3 to the left because I'm dividing by 1,000. 0.360 or 360 thousandths gram. Please remember to report units. Here's another example. We're going to be calculating volumes this time. We need the patient's total fluid intake for a day if she had the following. So we need to find some way to add up all of these, even though we have ounces here, we have teaspoons here. Those look like the 2 different units in this problem. We do not have a conversion factor that I've asked you to memorize for ounces to teaspoons or teaspoons to ounces. So let's just combine like terms first. So I'm going to add up my 8 ounces of milk, 6 ounces of juice, 8 ounces of water, 6 ounces of soup, 12 ounces of caffeine-free soda, and 4 ounces of Jell-O. I add that up, I get 44 ounces for daily fluid intake, but I am not done. I need my answer in milliliters. So I'm going to take my 44 ounces that I have here, and I am going to find the conversion factor that will change those ounces into milliliters. So 1 fluid ounce equals, well, let's write it this way, 30 milliliters. And now my ounces cancel. It leaves me milliliters. So let's see, 30 times 44 is 0, 12, carry 1, 13, 1,320 milliliters. Still have to convert those to teaspoons. Okay, so I'm going to do a conversion. I need to convert those to milliliters also. So how many milliliters in 1 teaspoon? 5. Okay, teaspoons cancel, leaving us in milliliters, which is what we want. And 2 times 5 is 10. 10 milliliters. Now, all of that liquid was converted from ounces to milliliters. We did the last bit of it from teaspoons to milliliters. So now we can add these two. And there's our answer. This patient had 1,330 milliliters of fluid today. Now I need to say a little bit about apothecary measures and about this rather strange unit, GTT. It is actually from the Latin word, an abbreviation of the Latin word for drop. That word is either gutta or gutta, depending upon who you ask. It's a dead language. I don't know. So 1 gutta equals 1 drop. Remember, this is a practical course, so the answer is, it depends. It depends upon the tubing from which you are dropping the drop, or the syringe, or the dropper. Imagine that, from which you are dropping said drop. As you continue in your nursing education, you will learn how to calculate the size of each drop for specific situations, but I'm just here to give you the basics. For our purposes, okay, we are going to let 1 milliliter equal 15 drops, GTTs, okay? So 1 GTT would be 1/15 of a milliliter, which is an awkward unit, but it is sometimes used if you are setting the rate of droplets of medication being added to an IV. That's often where you're going to see this. Let's work an example. We will start this example with what we're given. 100 milliliters per hour. That's how much medication we want to give the patient. How many drops per minute? Let's get rid of the hours first, convert that to minutes. So we will use 1 hour over 60 minutes so that we can cancel those hours. And now we need to convert from milliliters to drops. So 1 milliliter equals 15 GTT. All right. What have we canceled now? Well, we canceled our milliliters. We canceled our hours. The units that we have left are our gutta, or guttas, and minutes. So 15, 60, and 10. Let's see if we can go ahead and do a little bit of math on this. 10 goes into 10, or 100 10 times. 10 goes into 60 6 times. Let's see, 3 goes into 6 2 times. 3 goes into 15 5 times. And then 2 goes into 2 1 time. 2 goes into 10 5 times. I have ones straight across the bottom. So now I'm just going to multiply 5 times 5 to get 25 GTT per minute, or drops per minute. I would like for you to consider one more thing. Let's consider a quart in the English system, the household system, just 1 quart. And how many milliliters is that? Don't look at your chart yet. Actually, I'll go ahead and give you this conversion. 1 cup equals 240 milliliters. That's from your chart. So let's see what we can do. If 1 cup equals that, we have a quart here to start with. So we need a conversion factor. Let's see, 1 quart equals 2 pints. 2 pints. And 1 pint equals 2 cups. Let's see, I'm going from quarts to milliliters. What have I canceled so far? I'm down to cups, and now I can use the conversion factor I gave you. So 1 cup equals 240 milliliters. And I have canceled everything across through there. I just need to do the calculation now. And I get 960 milliliters. Okay, now look at your chart. We just calculated that 1 quart equals 960 milliliters. But on your chart, you have instead that 1 quart equals 1,000 milliliters. Or do you? Actually, it says 1 quart is approximately 1,000 milliliters. And if you round up, you get 1,000 milliliters. And when I wrote this 1 cup equals, remember, it's an approximation. So that means there's a little bit of error in there. There's a little bit of rounding. If you rounded to get this value, 1 cup equals 240 milliliters in this conversion factor, then when you multiplied that by 2, that made the error a little bigger. Here, the error was a little bigger. So you have different values depending on which approximation you used. Neither one is wrong per se, but for a given application, one may be a better approximation than the other. We could run through lots more examples, but in each case, if you know the conversion factors or can form a conversion factor from the problem, then you just apply dimensional analysis until you are left with the units you need. So I don't think you necessarily need for me to keep going with examples. However, if you do have questions, please contact me and I would be happy to discuss them. But see, conversions aren't that bad.